This is Anurag Kumar alongside his teammate Wasim Khan, and this will be our submission for the Into the Scrapeverse hackathon by WeMakeDevs and Bright Data. Bright Data is this brilliant software that helps us create our own web scrapers to scrape data from websites, and it has this brilliant feature called self-healing, which detects the changes that has been done in the website or the code that is being presented on the website and heals that so that the data is not lost or it is not corrupted, right? But what our product does is that it verifies the heal that is performed by Bright Data, because according to Bright Data's own documentation, it describes the self-healing as a human in the loop by design, which means that every fix that is performed by Bright Data needs to be reviewed by a human. So that's what we did. It created a layer of AI verification on top of Bright Data self-heal, which checks that the heal worked perfectly or not. And how we did that is we tested our scraper pipeline by four scenarios, like swapping the price and ID of the product that was present by dropping an entire field in the JSON response, by multiplying the price by 10 times, or by changing the variable name itself. And as you can see, the first three cases, it needs to be rejected because it completely changes the meaning of the data, and that is the expected verdict, and the actual verdict is also reject. So the result is correct. But the fourth one is just changing the name of the variable. It doesn't change the meaning of the data. So for that, we don't need to reject it. We can approve it, and it was approved. So with this way, we checked if our AI gateway or AI trust control gateway can actually work as intended, and it did. Now looking at the architecture, so the data layer where we have Postgres, NeonDB for storing the data of the runs as well as the heal events, how many heal events has occurred, and we have Redis or Upstash for the queuing of scheduled jobs. For a presentation layer, which if time allows us we'll see, we have Next.js dashboard. For data sources of scrapers, we are scraping books to scrape.com, codes to scrape.com, as well as chroma.com and Vijay Sales for actual data and comparison. Then for the orchestration layer where the actual magic happens, we have BullMQ scheduler for scheduling the jobs, run worker which extracts, normalizes and persists the data from collections, the drift detector using Zod and Grok, which actually detects the changes in the data between the runs, and then the heal worker, which is triggered whenever there is a change in the data. The bright data layer, where you have the collector, the dataset polling happens, the self heal engine, as well as the approval gate, and then the AI trust gate, where Grok, which we use in our logic, reviews the change in the data, and based on that gives a verdict. And if the verdict is safe, it resumes the job and stores it in the DB. So that was our architecture. That was our application. You can also see the UI which we've created. Here, right here, the number of runs, the listings collected, the heal events, the trust gate accuracy, the four cases that I just talked about. You also have visualizations for better understanding, and in-depth rejections and approvals of the heal events done by Bright Data Scraper, and then the verification done by our actual application, the active collectors and their status, and then the actual use case implementation of the data collected, which is comparison of MacBook pricings, right, across Chroma and Vijay Sales. So this can be a huge, you can say, application implementation of the data that is scraped by us, and this is the data that we've presented here. And to make our accessibility better, we've also created the UI in dark mode and light mode. So that was ScrapeTrust. Thank you.